go, folks. We are going to start with a couple of warm-up problems today, and then we'll get into your notes. We're doing more of the same stuff that we did yesterday, okay? Another day of practice on it before we move on to something different. Take a look at your first warm-up problem. It says, which is a factor? There's that F word again, right? Factor? Somebody tell me what it means, a factor, from yesterday. What's it mean? You could group. What's that? You're trying to figure out the original multiplication problem. So if you are looking at this polynomial right here, does everybody see it? I want to know what was multiplied together to make that. And normally in algebra, we use parentheses to denote multiplication. So your answer is going to have some parentheses in it. Now, how many terms does this thing have? 4. So how do we do 4 terms? We group them. So if you will please group them 2 by 2. 2 by 2. We'll start with Dalton. Dalton, what can you take out of the first group? Can I divide 6 and 3 by the same number? By what? No, you're right. What can I divide 6 and 3 by? By 3. Is that okay? Both of those are divisible by 3? Okay. So we're going to pull a 3 out front. Now, do they have a variable in common? What? A z. So both of these are getting divided by 3z. How is that for everybody? Okay. Savannah, make sure you speak up in case you got any questions for me, okay? All right. Dalton, 6 divided by 3 is, and then what about my z's here? 1z. Perfect. And then a minus. Now what about here? Do the z's cancel? What is 3 divided by 3? So folks, sometimes I tell you the 1 is, you don't need it, correct? But if you look at this problem right here, there's nothing else left, is there? So you have to have this 1. Have to. Tyler, back to you. What does the next parenthesis start with? What symbol? Negative. So I need to start with a negative. Now, what can you divide out of both of those, Tyler? 2. So we will be dividing by negative 2. All right, sir, what is negative 2 divided by negative 2? Do you need that 1? I do, because there's nothing else left. Okay. What is 4 divided by negative 2? And a z. Good. Folks, do I have a repeated factor? They are opposites, aren't they? So remember, I'm going to drop down my first repeated factor. And then because they're opposites, this is going to turn into what? What's this going to turn into? It's going to turn into plus 2. Okay, because opposites of numbers, one is positive, one is negative. So if this is negative, I am then going to turn it positive. Okay, so Savannah, we talked about opposites yesterday. Do you agree that this 2 is positive, that 2 is negative? They're opposites, right? This 1 is negative, that 1 is positive? They're opposites. Okay, so normally these two things would be identical, and you would just write it right here. But since they're not, I'm just going to drop down the first one, and then I'm going to make whatever in front of the second one the opposite. Does that make sense? So this one got dropped down, and because that 2 is negative, I then turn it positive because they were not identical. We'll do some today where they are identical so you can see how it's supposed to work. Okay. So folks, what's my answer up there? B as in boy? I don't think so. A? I don't think so. Okay, so folks, they're asking you for a factor, correct? This is a factor, and this is a factor. It's definitely D. 2z minus 1 would be right there. Is that all right for everybody? Because it definitely wasn't all right just a second ago. This is okay? All right, take a look at the next one. I have a graph for you, and I want to know which of those matches the graph. What do you see on this graph? A shaded area, which means I have to have a greater than or less than symbol, correct? Are we shaded above that line or below that line? Above, which means I want what kind of symbol? No. A greater than symbol. If we shade above a line, that means it was greater than. So which of these are not greater than? A and Those are both less than symbols. Is that okay? Okay, what else do you see on this graph? It's not equal to because it's dashed. So it is C, it is not D. Now, folks, isn't this slope-intercept form? So where should this line start? At 3 on the y-axis, which is right there, isn't it? Guys, I'm up here, right here. And then where should I go from there? 1, 2, 3, 1, 2, 3, 4. That is most certainly that line, isn't it? Good to go? Okay, so we're going to practice on the front. You can see the same type of questions that we had yesterday. And then we flip it to the back, and we're going to add another step to it. Okay, so let's fill in the vocabulary from yesterday. Yesterday, we talked about what it means to factor. In fact, when we started this lesson today, I told you what it means to factor. What does it mean to factor? You want the original multiplication problem. The original multiplication problem. And we've said before that normally we have parentheses to mean multiplication. Okay. What is a GCF? Greatest common factor. And if it's the greatest common factor, it has to come out of all of the terms. Well, because it's going to go in the front of the parentheses. You're right. It's just not the answer that I was after. Okay. So the greatest common factor, what does every term have in common? Notice the underlined word there of every. It can't just come out of one term. It can't just come out of two terms. It has to come out of every term in order for it to be a GCF. Excuse me? Correct. Yes, ma'am. The coefficient has to be true of that, and the variable has to be true of that. Everybody doing okay? Can you kick that towards him? Thank you. All right, last but not least, factoring by grouping. When do we use grouping? When there's 4 terms. Perfect. And then how do we group those terms? How? 2 by 2. Perfect. Perfect. Now, I'm going to pull the square away, and I don't want you to write the last 2 things, okay? I'm most concerned with this. Once we group them, then we're going to look for a GCF. Then we look for our repeated factor and our leftover factor. Is that all right for everybody? As usual, we are not going to do all these problems. We're going to move around, and then whatever is left over is left for you to do, if you so choose. Always. So here we go. Let's start with number 2 in the middle, please. Do you have a GCF that you can take out of 30, 1, and 6? Does everybody agree there's no number that can come out of all of those? Okay, but we are in agreement that the P can come out because they all have a P. Do they all have an M? They don't. So I can only take out a P, which means I'm going to divide all of these by P. Wonderful. So if I didn't take a number out, this 30 just gets dropped in. If I didn't take an M out, that M just gets dropped in. Now, what about my P's? Just 1, because this is a 2, this is a 1, 2 minus 1 is 1. Then I have a plus sign. Again, I took no M's out, so this M squared is getting dropped right in there. How about these P's? They cancel. No P, because P on top, P on bottom cancels itself out. And then I have the minus 6 and no P's. Again, see that, Savannah, how they cancel out. So this would be my final answer. What do you guys think? Fair enough? Okay, that's the only one I want to do in that row. Okay, let's go down to the second row, please. Let's start with number 4, if you would. What's wrong? What can you take out of 9 and 3? Hold on. What can you take out of 9 and 3? 3. And then you tell me an x as well. So both of these are going to get divided by 3x. Okay. Now, this says 9 divided by 3, which is 3, and x squared over x is just x. And then finally, I have minus. Do you notice how the top and the bottom matches here? So in essence, everything cancels out, correct? I need a placeholder, though, of a 1. If my original problem was a binomial, my parentheses also has to be a binomial. Okay, let's go over to number 6. What can you take out of 45 and 15? Is everybody all right with 15 here? Yes? Can I take any variables out? Just an r? Do you see how there's 3 in the first one and 2 in the second one? So I can take out an r squared. So we'll divide by 15 r squared. Okay, let's see what's left here. 15 divided by 5 is 3. Now, how about the r's? We doing okay with 1r? Minus. Okay, we're going to go back to going around the room here. Let's take a look at number 8, please. Cody, I'm up to you for number 8. What can I take out of 55, 11, and 44? 11. Can you take any variables out of that, sir? P squared is perfect. So we're going to divide all of these by 11 p squared. Okay, when we do that, Cody, what is 55 divided by 11? Wonderful. What happens with these p's? They cancel. Minus, what's 11 divided by 11? I don't need that one because I'm going to have some p's left over. How many p's do we have left over here? Good. And then plus. Perfect. Is everybody following Cody there? Do we have any issues with that problem at all? Everybody's all right? How about the rest of you? You guys over here good? You guys over here good? Okay, let's move on to the next row. How about number 11 there in the middle, please? Okay, take a look at 11. So you need to be asking yourself, can I divide 4, 28, and 7 by the same thing? So, Logan, can I divide 4, 28, or 7 by the same thing? No, so there's no number that can come out. Do they have any A's or B's in common, Logan? How many A's do they all have? Just one, and the same for B's? Perfect, so we're going to take an A, B out. Now, since we did not take any numbers out, that 4 is going to drop down. I have A squared over A. What does that leave me with? A squared over A, excuse me, A squared over A, what does that leave me with? Wonderful. B over B, gone. Now we have a plus 28. This says A over A, that's gone. How about B squared over B? Good. And then plus the 7. A's gone. B's gone. Is that okay? How we doing following Logan there? Everybody's all right? Let's get to some grouping ones. Dylan, 14. 14. Does everybody agree this is 4 terms? Yes? Automatically, we're going to group 2 by 2. So, Dylan, what can I take out of the first group? There's something going on out there? What's that? You would not. You would not. Not in this case. If I was asking you to simplify them, then you would. But since we're factoring, we're not going to. Dylan, what can you take out of this first group for me? Wonderful. So the 2y goes in front. Can you tell me what would be left, sir? Wonderful. Now the next parenthesis starts with a plus, so I start with a plus. What can you take out of the second group? 1. There's nothing but a 1. So you have to use 1 here. Now, if I divide these by 1, Dylan, what do I get? Minus 2, you say? How is this for everybody? Do you have factors that are identical? You do. And then, Dylan, what would be your leftover factors? Perfect. How we doing here? Fine? Savannah, you feel caught up enough for 15? All right. So do you agree there's 4 terms there, ma'am? So let's group them 2 by 2. What can you take out of the first group? 4m. So I'm going to divide them all by 4m. And what do you get? Wonderful. What does the next parenthesis start with? So we're going to start with a positive. What can you take out of the next group? 3p is going to get divided out. And then what would be left? Okay, do you have identical factors? You do. So we're going to pull out the m plus p. And then what would be left over? Perfect. And Savannah, we talked about this yesterday. So now that we have this answer, this would be something that in the last section, can you see okay? Something in the last section that you would cut this in half and then distribute, which would look just like this, wouldn't it? Make sense? Okay. Let's see Grace said though. All right, are we at the bottom row now? Yes? All right, let's just do 2 more and then we'll go to the back. Luke, you pick. Which one of those across the bottom would you like to do? All right, let's group them 2 by 2 because I've got 4 terms. What can you take out of the first group, sir? If you divide those by a, what's left? Wonderful. What does the next group start with? Well, hold on, what symbol? No, what symbol here, Luke? What is that? Plus, so you're going to start this with a plus. You have to have a symbol in between there. Now, you're telling me, though, that I can only take out a 1? Yes. So if I divide these by 1, what do you have left? So do you have identical factors? So that would be the x plus y. And then what would be your leftover factor? A, and then plus 1. Is that okay? Derek, your choice, 16 or 17? 17 it is. Group them, please. What can you take out of the first group? If you take out the 3a, what's left? Yep. What does the next group start with? Okay, so what can I take out of those 2? Yep, so we're going to divide these by -2 now, folks. What will be left? Got it. Do you have identical factors? Okay, so that would be the 4a plus 1. What would be left over then, sir? Good. Anybody have any issues on the front before I add a step for the back? No? We're going to add a step next, yep. I know. We sure we're okay? All right, here we go. I want to know, how do 2 factors that are multiplied together be 0? If I have 2 numbers and I want to multiply them together and I want it to be 0, doesn't one of those numbers have to be 0? That's the only way you can multiply to be 0. Agreed? Okay, so let's fill that in. One of the factors must be 0. Has to be. Because anything times 0 is 0. So we have this thing called the zero product property. Zero product property. And it says basically what we were just talking about. If you want the product to equal 0, then make one of the factors equal to 0 and solve it. Okay, if you want the product to equal 0, then set each factor equal to 0 and solve. Now, here's what I need you to realize, and I don't know if I was very clear about this yesterday or not, but I'm going to try and make up for it today. Does everybody see this number 1 right here? This is a factor, and this is a factor. This is a factor, factor, and factor. Does that make sense to you? Okay, so factors are the things that are in parentheses. Okay, now this part where it says solve right here, I don't need you to write it. We're just going to talk about it. You need to ask yourself, or you're going to see here, some are already factored for you, and some of you will have to factor first. How do we know if it's already factored? The parentheses. Do you see how the whole first row is all parentheses already? That has already been factored for you, which means it's going to be much easier. Okay, that's a good thing. Now notice these are all set equal to 0, yes? So if I want x minus 9 times x minus 2 to be equal to 0, either this thing has to be equal to 0 or this thing has to be equal to 0. Agreed? So do that. Now this should be very easy for you to solve. How do I isolate the x? Correct, x does equal 9 because I would add 9, and now the x is alone. Is this okay for everybody? Now over here, I would also add the 2 to isolate the x. How is that for everybody? And those are your two answers. Now here's what I want you to understand. If I were to take either of these two numbers and plug it in, it's going to make it be equal to 0, correct? Let me show you. And again, don't write any of this. I just want to show you. If I take this 9 and I put it in right there, what is 9 minus 9? Does it even matter what this thing is? No. If I take this 2 and I put it in right here, what is 2 minus 2? Does it even matter what this thing is? No. These two are both answers to this problem. That's it. I know it is. I know it is. So what are you going to do in number 2? Well, first you're going to set them equal to 0, obviously. And then subtract the 2. So what's x? What's x? Negative 2. How about over here? Add the 5 and you get 5. That is literally the answer. I swear. It's not. It's not. Now, folks, how many factors do you have here? 3. So I'm going to set up 3 equations. 5n has got to equal 0. N minus 3 has got to equal 0. Or n minus 4 has got to equal 0. So this will now give me 3 answers because there's 3 factors. How do you solve the first one? So what's n? Okay, how do you solve the middle one? So n is, how do you solve the last one? So n is, what do you guys think? Can you handle that? Yeah? Think so? Okay, you do number 4 then. And when you're done with that, do number 5. No, just 4 and 5 for now. Haley, you still doing okay back there? Number 4, number 5. Did you get 3 and negative 4 for the first one? Yeah? Over here, you should have gotten 0, negative 5, and negative 2. How'd you do there? Does anybody want to talk about those at all? No. You're positive? Yeah. Okay, so take a look at 6 and 7, please. What do 6 and 7 not have? They don't have parentheses, so you have to make them. But that's fine. You know how to do that. It's just factoring. So this thing has 2 terms. Tell me, is there a GCF of 8 and 32? 8 is the biggest I can take out. How about any variables? So I'm going to take out an 8y, and I think I'm back over to Tyler again. Tyler, if I take out 8y, what's left? Y. Now, y squared over y is just y, right? And then minus, what's 32 divided by 8? 4, and those y's cancel, right? How's everybody doing with that equation? Now, doesn't that look like the ones we just did? So what are we going to do with both of those? Set them equal to 0, and then we'll solve them. You are perfectly correct. How do you solve the first one? How do you solve the second one? And these would be your two answers. Put it right here for me, and you can head back downstairs then. Thank you. Have a good weekend. Folks, let's do number 7. Again, there's no parentheses, right? So you got to make them. So, Cody, what can I take out of 8 and 40? Higher. 8. Can you take any variables out of both of those? B's. So I am going to take out a GCF of 8b. If I divide them both by 8b, Cody, what's left? Yep. What is 40 divided by 8? And then how about those b's? They cancel. So now it looks like that. And folks, again, this just looks like the problems we were just doing, doesn't it? So set them equal to 0, and let's solve them. How do you solve the first one? So b is, how do you solve the second one? So b is 5. There we go. Fair enough? All right, one last type of problem to do today. What's different about the next one? What's that, Savannah? It doesn't equal 0. Dylan, you okay? You over it? We done? Yeah. It does not equal 0. Do you see how the one side does not say equal 0? So you got to get it equal to 0. How do I move this 3c over? It's positive, isn't it? So to move it over, I would subtract it. Now, do the c squareds and the c's go together? They don't. So you're going to leave it as c squared minus 3c and then equals 0. You can. Can you check on Dalton while you're in there? Yeah. I'll say that. What can I take out of both of these? I'm up to you, Logan. What can I take out of both of these? Perfect. So the c goes out front. If I take out a c, what's left? It was squared, then I took one out, so now I have just a c minus, how about over here? How about over here? What would be left right here? Yep. And now we're back to solving. Either c has to be equal to 0 or c minus 3 has to be equal to 0. You guys see how this problem is already done for you? The variable is already isolated. That's it. This is just the answer. Now how do you solve this one? So c is 3. How many I got left in that last row? 3. Extra credit. Can I just do 1 and then the other 2 will be extra credit? Fair enough. I'm to you. I want to do 11. How do I get it equal to 0? We can go this way, right? All right? Well, how are you going to rewrite that then, Savannah? Do those go together? Oh, do those go together? y squared and y, can I put those two things together? No. So I'm going to have 12y squared minus 4y. Is that okay? Now, what can I take out of both of them? Anything else besides the 4? Y. So the 4y is going to go out front. Bless you. What's left, ma'am? Good. Notice we've got to have that minus 1. So now we're going to set these equal to 0. How do we solve the first one? So y is 0. How do I solve the second one? And then? Now, does 1 divide by 3, Savannah? So I'm going to leave it as 1/3. Or 0.3 repeating if you wanted to do your decimal representation. So that'd be it. Anything left is for you, so if you so choose. And this will be your homework. Yeah. I will look.